Hi everyone, please take a seat so that we can get the session started. We are running about 5 minutes late. So welcome to this session. This session is, the topic is quantitative social science and conceptual frameworks. And my name is Violet Chen. I'm happy to chair this session. We will have 4 talks, and each talk will be 15 minutes with 5 minutes for Q&A. As usual, we'll take questions from offline audience first, then go to online audience. And without further ado, let's welcome our first speaker, Zhao from Georgia Tech. She'll talk about a model for wealth disparity. Let's welcome Zhanzhan.
Hello, everyone. My name is Zhao, and I'm a PhD student from School of Computer Science in Georgia Tech. It's great to meet you guys here. Today, I would like to talk about my work with my advisor, Professor Randall, on our proposed heterogeneous Schelling model. And we would use the model to show you how wealth disparity would influence segregation and civic infrastructures to potentially help mitigate it. So here is a map of Atlanta, where each dot represents a person. Well, the green dots represent African Americans, the blue dots represent Caucasians, and we can see clear segregation pattern here. Actually, Atlanta is not alone. These days, in many US cities, segregation is a still very severe problem after the Fair Housing Act of 1968, and we would like to ask why. In the literature, macro-scale factors were studied, like demographic characteristics, public policies. These factors are usually studied, showing the correlations between them with segregation. There's another thrust of work trying to understand individuals' influences on segregation. The most famous work is by economics Thomas Schelling, who showed how individuals' racial biases over their local neighborhood might influence segregation globally. So to be more specific, over 50 years ago, Thomas Schelling modeled agents living on the checkerboard. They are either of color red or blue. Locally, everybody is making a local decision about whether they want to leave their current neighborhood or not. So they will become unhappy if more than a certain threshold of neighbors are of different color as them. So when they are unhappy, they would deterministically move away and try to find somewhere else to live to see they will be happy there or not. So if everybody behaves like that, globally, when that gets added up, after a long time, we would observe the emergence of segregation. Thanks. So over the years, there has been extensive work being done to try to extend Schelling's model in order to better mimic the social dynamics in the real world. So in statistical physics and computer science community, the so-called effect of micro motives influencing macro behaviors is also well understood, and the rigorous proofs about phase transitions are being done there. For example, recently, Sarah Cannon and her co-authors proposed a stochastic Schelling model. So the different model becomes stochastic, and that is helpful in order to capture the uncertainties and the random disturbances in the real world. And phase transitions are proved. Under strong homophily, we will be very likely to observe segregation, and with weak homophily, which is weak racial biases, integration is proved to be more likely to occur. However, there also exist limitations in this line of work because they're usually being oversimplified. They're so simple that they cannot review some very important aspects of the reality. For example, when we talk about segregation, urbanized segregation is also usually observed where we can see one racial group clusters near the city center. Also, city centers can also disproportionately attract the poorer populations, which is known as urbanization of poverty. But these effects were not be able to be captured by those models. So our work would like to fill in this gap. We would like to extend the stochastic Schelling model to make it a bit more complex to incorporate important aspects like socioeconomic incentives. Yet we also want to maintain the ability to make sure we are able to rigorously prove things compared with a lot of simulation-based models. And we believe that doing so, we could be able to provide better insights about the causal mechanisms of a few key factors' global consequences. So now let me introduce our proposed model. We call it the stochastic heterogeneous Schelling model. It is being heterogeneous in two ways. First, we introduce the concepts of urban sites. So we imagine agents are living on a triangular lattice, like this picture shows. You can see a lot of rings there, right? So each ring represents a residential location, and it can accommodate at most one agent, regardless of its colors. So compared with the models previously, we introduced some yellow sites there. They are called urban sites, and they provide incentives for the low-income agents to stay. Urban sites could be allocated in centralized ways. Like you can imagine a city center with high concentrations of all kinds of amenities, including malls, stadiums, and so on. It can also be designed in more distributed ways, like cities with the bus routes equally spanning the entire city. So the second way that our model is heterogeneous is because we introduce another dimension. So agents, instead of just being blue or red, they can also be being rich or poor. So in this way, now we have 4 types of agents. They can be poor blue, poor red, and rich red. And we use cyan and pink colors to indicate poor agents whose color are lighter compared with dark blue and dark red. Urban economists try to explain urbanization of poverty by saying that city centers really provide amenities that can benefit the poorer populations more, like public transit and so on. So we want to capture that incentive in our model. So in our model, everyone, regardless they are being poor or rich, they still have the racial biases. Like we just talked about, everyone would still be more likely to move away if more neighbors are of the different color as them. But on top of it, if an agent is poor and he's now on the urban side, he might be a little bit more hesitant to leave in spite of the racial biases that he inherently had. So in this way, the so-called incentive, we capture it by the parameter gamma here, which is also called economic incentive. And it acts like some sticky force for the poor on the urban sites. So at each time, we would randomly activate 2 agents to make them think like that. And we repeat this process long enough until the configuration does not quite change anymore. It is a Markov chain, and using tools from theoretical computer science community, we are able to prove that this Markov chain is ergodic and it has a stationary distribution. And using detailed balance, we're able to prove the stationary distribution like theorem 1. So now let me show you our results about different scenarios at stationarity. The first, we asked, what if economic incentives are high? And we showed that at this case, no matter racial biases are big or small, we would have very high probability of observing most of the poor agents occupying the urban sites at stationarity for big enough cities. So to prove this theorem, it suffices to prove that in the state space, the configurations that are non-urbanized have exponentially small probability. To do that, we define a mapping to map those images that are non-urbanized to images that are urbanized. And we prove that the images of the map have exponentially larger probability than the pre-images using tools from statistical physics community. There are two difficulties in this proof. First difficulty is that actually in a state space, there are far more non-urbanized configurations than urbanized ones. The second one is that because we extend the state space by another dimension, we added the socioeconomic status dimension, right? So now, even for those non-urbanized configurations, some of them have very big probability weights according to their racial bias terms. So those things require more complex trade-offs and more careful counting techniques. And we adapted the tools used to prove things there in statistical communities to finish our proof. Then we also try to investigate what happens if both racial biases and economic incentives are high. And we show that for centralized urban sites with wealth inequality across races, we would observe the urbanized segregation of one race at stationarity, like this picture shows. Our third theorem also considers about the case what happens when all the other settings are the same, but there exists no wealth inequality. At this case, if both biases are high, we still get segregation, but we would no longer observe segregation of one race on the urban area, but like there would be both poor blue and poor red occupying the urban area, like this picture shows. Notice that because this is a torus, so the left side and right side, they are connected, top and bottom, they're connected, so segregation phenomenon is there. We find one phenomenon very interesting. So we find that even if racial biases are small, as long as there exists wealth disparity with centralized urban sites, when economic incentives are high at stationarity, we could still find high probability of observing urbanized segregation on the urban area, although we will also have very high probability of seeing integration outside. So what this tells us is that even if there exists little to no racial biases, as long as there exists wealth disparity, it can be enough to cause urbanized segregation. And we prove that using tools from statistical physics in theorem 4. How about now we distribute the urban sites? And we find that under this case, even if wealth distribution across races is still very imbalanced, even if racial biases are still very big, but as long as the economic incentives are high enough to overcome the racial biases at the stationarity, under this case, we would have exponentially small probability of observing big segregated clusters for sufficiently big cities at stationarity. So if we place the results of urbanized segregation of the red and our results of mitigation of the segregation together, we would find that every setting are the same. Like the racial biases are the same for these two settings. The economic incentives are the same. And even the urban size fractions are the same. Also, there both exist wealth inequality across races, and that that fraction is also the same. But just because we now distribute the urban sites more equally, it's enough that we observe a lot less segregation at stationarity. And yes, we think distributed urban sites would make a difference to mitigate segregation. So now let's conclude our paper. So we propose the stochastic generalization of the Schelling model based both on race and wealth to understand how carefully architected placement of incentives, such as urban infrastructure, might affect segregation. And we proved a set of scenarios. We found two very interesting. One is even when homophily preferences are very small, if incentives are big and there exists income inequality, we can still get racial segregation with centralized urban sites. And another proof is about mitigation of segregation through distributing the urban sites. And so if you are interested in what happens in reality, we also find some similar configurations in Metro Atlanta and Metro Detroit, where we can see urbanized segregation and the minority cluster, which is in black shades. They are concentrating in areas with high concentrations of public transit. So that's all. And thank you. Any questions?
Thank you for the talk. I'm not very familiar with the Schelling model. I mean, can you explain to me if there are any variants of the Schelling model that talk about barriers to entry? So I would argue, or according to me, I mean, the reason there is segregation is because new people who come into neighborhoods and have to decide which neighborhoods to move into, they are either disincentivized to move into particular neighborhoods, or they, by their own preference, they end up moving to particular neighborhoods. So whereas in the Schelling model that you're talking about, you already have agents who are already living in community, and there's no introduction of new agents. So how would the results translate to settings? And is there any research that's happened on, continuously newer agents coming into the system, and which is, I would argue, an important piece of the system?
Thank you for your question. Yeah. So that's a good question. Actually, so in our set of models here, we talked about closed cities, but in my advisor's previous work, they also modeled open cities. Like you just said, there could be some newcomers of the city. Yes, I would say yes. There are work studying it, and yes, it's a very interesting problem because, like, for example, in Germany these days, we see many new immigrants, and what kind of effect that will happen for the local area in the long term. Now, that's a very good question. I would like to study it in the future. Thanks.
Hi.
Hi.
Can you hear me?
Yes.
Oh, this is better? Oh, okay, great. My question was the charts are very clear that when you distribute the yellow, like, urban amenities, that it makes things better. I guess my question is, how is that different than what it is currently when we have these, like, metro lines that kind of go out to various areas but still pull people back into, like, the center? I would argue that in that case, there are those urban amenities in some sense that are further out, but that still are leading to this kind of segregation. Is there some other type of amenity that you're thinking of for that, like, distributed pattern? Just curious.
Thanks for your question. So, yes. So, actually, what we would advocate is, like, for example, for public transit, that would evenly distribute it throughout the city. But if you look at the whole city, the whole metro areas picture, for example, in Atlanta and in Detroit, often we would find those public transit, they are still concentrated a lot more in central city area. So we still consider that as centralized urban sites. When it comes to other types of amenities, yes, there are also other types of amenities like education, healthcare, art and entertainment and recreational humanities, these types of humanities, actually they are actually prioritized more by the rich people. So we didn't study that in our model here. We only consider incentives for the poor, but we think our work can be easily extended there to because it's symmetric, right? So, but that's also an interesting question. What if we mix both? Rich prioritize humanity and poor prioritize humanities. Yeah, we think that's a good research question, and we are trying to investigate. Thanks. Any other questions? Thanks.